Okay, this is a little video about naming of alkenes and haloalkanes. So we've seen how with alkanes we can name the compound by first finding the longest carbon chain. Slightly different when you have a functional group. So for example, if we have an alkene, for example, let's take again just the carbon skeleton. Let's put something like this. Let's have a carbon-carbon double bond there like that, and then we can have that. Let's put a carbon there as well. So let's say we have this molecule here. What we've got to do is we've got to find the longest carbon chain, but it's got to contain the functional group as well. So therefore, when we consider this, we've got to include that functional group. Now the question is, do we go that way, which will give us 1, 2, 3, 4, 5 carbons in our chain, or do we go the other way like that? And that will give us 1, 2, 3, 4, 5, 6 carbons in our carbon chain. Now that is probably the best way, rather than taking the very longest carbon chain, which of course would be that one there. 1, 2, 3, 4, 5, 6. Well, that's 6 carbons. So we had a choice, but what we want to do is we want to make sure that we have it in, have the carbon-carbon double bond with the molecule as well. So how do we go naming this particular molecule? Well, we've got our functional group there, so let's have a look at that. So there's our functional group. Along with our functional group, we have 2 branches. Okay, so we have all the components that we need there. We have our longest carbon chain, which is 1, 2, 3, 4, 5, 6 carbons in length, so it's going to be a hex. But it's also going to be an alkene because it contains that carbon-carbon double bond. It's an unsaturated compound, so it's going to be an ene there. So that's taken care of the functional group and the main stem. What we also have, of course, are our 2 branches. We have an ethyl 2 carbon branch. E comes before M in the alphabet, so we'll have ethyl, and the orange branch is a methyl. So we know it's ethyl, methyl, hex, ene. Now we need to put a few numbers in. We number from the end nearest to the functional group. Let's get rid of a few of these colours like that. Okay, and if we number this way, we can make that carbon number 1, number 2, number 3, number 4, number 5, and number 6. Our ethyl branch is on carbon number 3, so we can make that 3 ethyl. Our methyl branch is on carbon number 5, so we can make that 5. But we also need to number our carbon-carbon double bond, because there are possible places, other places where that carbon-carbon double bond can go. So we'll need to make that hex 1 ene, because it's between the first and the second carbon. So that's going to name from structure. If we go the other way around, say we have 2, 5 dimethyl hex 3ene. Let's see if we can work out how to go about making the structure from that. Work backwards. You'll notice that we've got an ene here, so that is telling us that it's unsaturated, we're going to need a carbon-carbon double bond. We can see, however, that the longest carbon chain with our functional group is 6 carbons. So let's put out our 6 carbon chain. We can now number it, and we number, convention says we number from right to left, but it doesn't really matter which way we number it. But I will follow the convention like that. And then we've got our branches as well. We've got 2 methyl branches, you'll notice, dimethyl, on positions 2 and 5. Well, let's put everything together, shall we? Let's start with the hex 3E. Now that 3 is telling us that the carbon-carbon double bond is between carbons 3 and 4. So let's put our carbon-carbon double bond there. And we can put our 2 methyl groups firstly on carbon number 2 and carbon number 5. Like that. Oh, sorry. Make that a carbon, not number 5. There we go. Okay, so we have that set, and all that we need to do then is I'll get rid of those numbers and just add the hydrogens. Remember, when we're adding the hydrogens, that we need to make sure that we've got 4 bonds to each of the carbons. 1, 2, 3. That makes 4. 1, 2, 3. This one, 1, 2, 3. This one here has 1, 2, 3. So we just want 1 there, 1 there, 1, 2, 3. Can't leave it like that. We've got to add the hydrogens because you'd be penalised for just drawing the sticks. And we have this as our structure. Now if we're going to draw or write the condensed formula of that, let's see what we've got. You'll notice here that we've got 2 CH3 groups attached at the end. So therefore what we'll do is we'll write that CH3 twice like that. Notice, of course, that one of those CH3s is part of the main stem. So therefore, when naming it, you've got to bear that in mind. Those 2 CH3s are attached to a CH2. No, it's not. It's attached to a CH, which is also attached again to a CH group. But that CH is a carbon-carbon double bond, CH, and then we have another CH, and then we have 2 more CH3s. And you can see once again that we have our CH3, 2 CH3 groups, one of which is part of the main stem, but we're still going to put it as CH3 twice, like that. When we come to haloalkanes, it's a very similar sort of process. So for example, we can have for example CH3, CH2, CHCl, CHCl, CH3, for example. Now if we're going to name this particular molecule, what we need to do is to first find the longest chain with the functional groups. We've got 2 functional groups here, 2 chlorines, and it's pretty straightforward that that is our longest chain. So we have, in this case, 1, 2, 3, 4, 5 carbons, so it's going to be a pentane. We've got 2 chlorines, dichloro, and where are they? For the lowest numbers, we'll number from this end, 1, 2, 3, 4, 5, and we can see that they are on carbons 2 and 3. It's 2, 3 dash. Get rid of that dash. 2, 3 dash dichloropentane. Don't forget that if we have other branches, you've got to include those again. So if we have, for example, CH3, CH, CH3 like that, CHCl, CHCl CH3. All that I've done there is added a methyl group, you'll notice, on carbon number 4. We always number from the end nearest to the functional groups, and the functional groups here are the chlorines and not the methyl group. So this would be, again, 2,3 dichloro 4 methyl pentane.